What's up guys, Laura here with STP, and I have a math battle video coming straight at you guys today. I invited Huzefa from Scalar Learning on my channel, and we are going to duke it out. So I picked 5 difficult problems for him. He picked 5 difficult problems for me, and we're trying to stump each other. So he's gonna post half of the problems on his channel. We've got half on my channel. And when we solve these problems, we're actually going to critique each other as well. So just a heads up, in the description, I put a PDF to the problems that you will see in this video. So you can go ahead and try them in advance and then play the video to find out if you got it right or not and to maybe see other approaches. It's all about being a math ninja. So you can see our ninja skills in these videos and figure out quicker and more efficient ways for doing the toughest problems on the digital SAT. Just a heads up, all these problems are picked from the question bank, so they're official College Board SAT questions. Before we get into the problems, make sure you subscribe to my channel and hit the notification bell so you don't miss out on any content for me to slay the SAT in August, October, whenever you plan on taking it. All right, let's get into it.
All right, guys. Well, I guess it's my time now to go. Let's see if Laura can stump me. So she picked, looks like some high difficulty questions, which is awesome. And we're starting with the trig problem. Okay, so I'm looking at this. The first thing I'm thinking, and this is just sort of how my brain operates, but I see a 3 and a 4 in a right triangle. So I know it's a 3, 4, 5. Again, I don't even know if this is going to be useful, but a lot of times information that comes to my brain, I want to write it in, include it in the diagram. Okay. Now it's saying, what is the length of NQ? I'm just going to highlight that so you guys know what the question is asking. It's asking for this length. So we're trying to find that length. And if I know that this is a 3, 4, 5, oh yeah, I might have to use a little bit of proportions. And the other thing is, when you have a right triangle and you drop an altitude like this, right, we're making a right angle down there, that means it's a mean proportional right triangle, meaning this triangle is proportionate to this triangle is proportionate to the big dog. Okay, so all I need to do now is set up a nice proportion and we're good to go. So let's see if I can do hypotenuse, leg. So I do, and I don't know this value, but I know the big dog. Okay, hold on, let me think about this for a second. Oh, I know what I'll do. I'm going to call this side X, okay, and I'm going to call the big side, or sorry, not the big side, the remaining part, since I know the big side is, the whole side is 5, I'm going to call this 5 minus X. Okay, now let me see if I can set up a nice proportion, because once I get that, I can get the green side. So I'll say, oh wait, and I can actually create something for this. Oh no, I don't need to. Okay, so what I'm going to say is, I'll say X over 3. And when I make a proportion like this, I like to label. So I'm going to do little leg. We'll say little leg over hypotenuse. And so now I know if I'm going to do another proportion, I need little leg over hypotenuse as well. So then let's go to the big dog. For the big dog, I have 3 over 5, right? The little leg over the hypotenuse. So 3 over 5. So we can at least start to solve for X and make our way up to this value. You may have a much faster way to do this, by the way. I'm just thinking in real time. So we're going to cross multiply.
I threw this at you. You've never seen this, so
yeah. Okay. So we got 3 times 3 is 9, and then the other side we have 5x divided by 5, and we've got 9/5, which is also 1.8. But whatever, I'll leave it like that. So now I know that this side is 1.8, and now we can use Pythagorean's theorem if we want. We could also use another proportion, but I'm just going to roll with Pythagorean's theorem. And it's the first thing that popped in my head. By the way, the main goal with all this stuff is I always want to give you, and I think Laura would probably say the same thing, we want to give you as many ways to solve it as possible. And what I often say is the best way to do a question is usually the first way that pops in your head. Not always, right? Maybe you want to dig a little bit deeper if you're the first thing that pops in is very inefficient, but you know, this is good enough, especially for a hard level problem. Okay, so now we get to this point, we're going to use a little Pythagorean's theorem here. So we're going to say 1.8 squared plus what is my x squared? That's what we're solving for, is equal to 3 squared. All right, 18 squared was at 324. So it's 3.24 plus x squared equals 9. We're going to minus 3.2, what is that, 65.76, right? And then I know that because I know, you don't have to know this. You can use Desmos or a calculator, but I know 576, the square root of that is 24. So if I square root, we get 2.4 C for the win. Boom. Okay.
I have to say
Pretty
a couple things on that. One, I am impressed that you know 18 squared off the top of your head and 24 squared off the top of your head, because everybody knows 15, but not everybody knows 18 and 24. That was impressive.
Yeah, it's because I do math all day, every day, like a lunatic.
All right. Is that okay if I erase some of this? I'll just show
Go for
another
it.
way.
100%.
Okay, cool. So honestly, I was lucky because I haven't solved this yet either, but I had more time to think about it
Mhm.
while you were working it out, which gave me an advantage. So I think I found a shortcut, like, or a shorter way to solve it. So since you said basically that the big dog is similar to the little guys,
Yes.
right?
Yes.
So 5 is the hypotenuse of the big dog and 3 is the hypotenuse of the little dog. So if we set up a proportion of little to big, we've
Yes.
got the little hypotenuse to the big hypotenuse, right? And
Yep.
then the big taller leg, if you turn that, if you
Yep.
rotate it sideways, is 4.
Yep.
And
Totally.
then we want the smaller, taller leg. We don't know that. So that's going to be our X. And then you can cross multiply and solve. So
Much
then
better.
you end up with, and that saves a little bit of time, but sometimes it's hard to see when you have those
Yep.
3 triangles in there, you know?
100%. See, and I was thinking, I knew it had to be a nice proportion, but that's the optimal way to do it. So the way I did it, I basically did some extra work in there. But this can happen sometimes, like in the moment, in the heat of the test. First thing that comes to you may not always be the best. That was amazing.
Exactly.
Okay, now let's move on. But that still counts, right? I still get the win
You
because I
still
got it
get the
correct. All
win.
right,
Yes,
cool,
that's
cool.
a W.
Okay. All right, here we go. Ooh, I love these. All right. So this is a rational expressions equation, we could say, or what are they calling it? Nonlinear equations. Okay, whatever. All right. So right off the bat, immediately when I see something like this, in terms of simplifying, the first thing that pops in my head is common denominators. That's kind of like a general theme that you might want to see, might want to think about. We're looking at fractions, et cetera, et cetera. There's also going to be a really easy way to do this in Desmos. A lot of times, God, I'm just so old school. Like I see it and I just want to do it algebraically, though this one's probably really easy in Desmos. But let me just go old school for a second. So when I talk about common denominators, the thing that I want to start with is anything that's factorable, I want to factor. And that's also a common theme in general. If you're not sure where to go and you see something that can be factored, just factor it and see where it takes you. So here, that's a difference of squares, and we got x minus 3, x plus 3. And that's dope because we have x plus 3 and x minus 3, meaning we don't have to do a crazy amount of work to get nice common denominators. So I'm going to leave this one as is with x squared minus 9. I can turn this and this into x squared minus 9 nicely as follows. So for the first one, 2x, since I already got an x plus 3, just add in an x minus 3 on the top and the bottom via multiplication. X minus 3 times x plus 3, of course, brings us back to x squared minus 9. And then the other side, we multiply by x plus 3 on the top and bottom, right? So now we have x plus 3 over that same denominator. Now, once we have the same denominator across, I'll use a highlighter so you can see this. We just go do, and we kill those denominators. Now we have a very nice quadratic equation. We have 4x squared minus, I'm going to go ahead and distribute, save a little bit of time. This is slightly dangerous. Only do this if you're really confident that you're not going to make a silly mistake, but I'm going to remember to carry that negative. So we're going to go boop, boop, and we got negative 2x squared and positive 6x, because again, the negative carries, equals x plus 3. Now we got this really nice quadratic. Let's finish it off. 4x squared minus 2x squared is 2x squared. 6x, I'm going to minus x. Again, I'm kind of doubling up steps just in the interest of time. 6x minus x is 5x. And then I'm going to minus 3 from both sides. And we got this. Okay, again, I'm going super old school here. I could already plug this into Desmos and get the answer a little bit more quickly. Just for fun, I'm going to factor. And so we got 2x here and x. And this is the way with the leading coefficient. You can use something called the star method, or if it comes to you, which it did come to me, so I'm going to show you how to factor it without using the star method. But again, you can use it when you have that leading coefficient. So I'm going to have a 3 here positive and a negative 1 here. The reason why is because when you FOIL it out, you're going to get 2x squared, then you're going to get positive 6x, negative 1x. That's going to add to that nice 5x. And then we got negative 1 times 3, which is negative 3. So we know we factored it correctly. My two solutions, therefore, is whatever zeros this out and whatever zeros this out. So this one is going to be positive 1/2, right? 1/2 times 2 is 1 minus 1 is 0, and -3. Okay, we got something funny, right? We got both answers showing up. And this is a possibility, especially when we have a rational equation, because there's a chance that one of these solutions is theoretically extraneous. So the way you check for extraneous now is you plug it back into the original. But I don't even really need to do that because I can tell this is going to zero out that denominator. And that's a no-no, right? Just like square roots and negatives, especially on the SAT in general, unless we're dealing with imaginary. So this one we can eliminate. And of those, this is the answer. And I know we could have done it, I think, faster in Desmos. But Laura, okay, give me your thoughts.
Yeah, but like I have to say, I appreciate old school. So thank you for doing that, because like that's the math, really, you know, and I think it's good for students to see that and to know it. Okay, so Desmos wise, I see an x squared. So it may not necessarily be a parabola because of what we're dividing by, but it is like kind of quadratic like, or like quadratic in nature. So if you're going to put that into Desmos, the biggest suggestion I have for all you students watching out there is don't have an equal sign in between, because what ends up happening a lot of times when you type it into Desmos with the equal sign in between, you get these weird straight up and down lines. So just like any quadratic, we want everything on one side, and then you set it equal to 0 to self. We'll subtract that 1 over x minus 3 to the other side, and then we're going to type all that in, and then we're going to look to see where it crosses the x-axis.
So zoom out. So we basically, you put everything in and you minus it, so now it's set equal to 0, right?
Yeah, but you know what? Why do the two fractions look different than the first one? Do you see that? Like, don't they look smaller? That's kind of weird.
Oh, probably because of this exponent.
Oh, okay. Good call. So there we see it touches at 0.5. So there's our solution. X is 1/2.
And you see, right, like, again, I kind of went the old school method. I clearly shouldn't have, right? This was substantially faster. I think maybe you could have shaved a nice solid minute or so off of that protocol. So make sure to use Desmos. Think about, and the important thing too is what Laura suggests is like how to use it. This made it so much easier than if you just typed in the equation as is verbatim. You can still do it that way. You'll still get to the answer, but I think this is nicer for interpretation's sake.
Yeah, do me a favor. Let's change that second minus sign to an equal sign. I just want to see what it looks like when you do have equals. Yeah, do you guys see how it's straight up and down now? Which is okay. They'll still give you the solution. I think that's right at 0.5, right? Mm-hmm. But you don't see the parabola or the curve necessarily. So if you need the graph and you want to actually see the graph, you don't want that equal sign in between. This video is brought to you by Preptly, the OG digital SAT prep app that's available in the App Store and in Google Play. Are you guys on your phone a lot? And do you have lots of extra time this summer to prep? Do you like the idea of just doing a little bit of daily practice, like 10 to 15 minutes each day? Then Preptly is probably the way to go. So go download that and get prepping now.
Question number 3. All right, which ordered pair is the solution to the system of equations above? All right, I'll tell you a few things. You know what? I may just do this in Desmos just because the last time I went so long. But the problem with Desmos here is we have radicals, right? And Desmos is going to spit out decimals. So you can still do it in Desmos. Okay, now in real time, I'm maybe like, you know what? No, I'm just going to go old school. But you can do it still in Desmos. And you just have to check what these values equate to decimal-wise. But I'm going to recant that last statement. We'll still probably show you in Desmos afterwards. But I'm going to do it old school. So it says a solution to the system. So when we're talking about solution, we need to first get some sort of substitution happening here. Okay. So I see, actually, wait, can I do eliminate? Oh, I can actually do elimination. So they set it up nicely. Usually I'm not going to think elimination when I got a linear and a nonlinear, but this one, they kind of gave it to us nicely. So let's follow that through. I'm going to add these together and I got x plus x is equal to 2x, negative y plus y is nothing. And the y's are gone. That's what we wanted. Then I have x squared and then I have 1 plus -3, which is -2. And now what do we have? We have a beautiful quadratic. So next I'm thinking zero product rule. Again, that you want that to be automatic. So I got x squared minus 2x minus 2, set everything equal to 0. Now this is really cool because I can solve for this. And since we see the radicals, that's your indication that this is probably not factorable. I'm probably going to go quadratic. And I'm going to use the quadratic right off the bat. And it's probably going to get us to the solution very nicely. So that's A, B, and C. Quadratic is negative b, which in this case is 2, plus or minus square root of b squared, which is 4, minus 4 times A, which is that invisible 1, times C, which is negative 2, all over 2A. 2 times 1 is 2. Okay. Again, this is the X value, right? So it's whatever is going to be here. And then we've got, let's see, negative 4 times negative 2, which is positive 8. 4 plus 8 is 12. So we got 2 plus or minus red 12 over 2. Be careful here. I've seen students make this mistake where you divide this and this right off the bat, or they'll just divide this, and you can't do that. You must divide everything by 2 if you're going to divide by 2. Luckily for us, radical 12 can be simplified to 2 rad 3. The reason why is because 12 is 4 times 3. You can take the square root of 4. You can't take the square root of 3. So 4 comes out as a 2. 3 stays in. So now I'm going to do it up here. Hold on. Let me do a little arrow so you see where I'm going. So we got 2 plus or minus 2 rad 3 over 2. Now I can divide both of these by 2 as well as the denominator, and we're left with 1 plus or minus rad 3. So we come back to these solutions, and since this is the X value, I see that it's got to be A. This is the only value where we have, or the only coordinate pair, I should say, solution, where we have 1 plus rad 3 in the X value. So we can pretty certainly say A is the winner. But you can also verify this in Desmos. You can go back, plug this in, make sure they intersect at that correct point, and then make sure that the X value of the intersection point is equivalent to this. Okay, Laura, give me your thoughts.
Love it. Love it. I mean, this old school, like, we're bringing back neon. We're bringing back the 90s. Like, this is what it's all about today.
Let's talk about the show Friends. Bring it back.
Do you watch Friends?
Of course. I watched it growing up. Of course. I mean, I did. When I was a kid, it was my favorite show. I always identified with Ross.
Okay. I could see that. You kind of look like Ross a little bit, too. I was a Seinfeld person, but I also did watch Friends, too. So, like, the only thing I would add is obviously we touched on Desmos, so we don't need to throw it in Desmos per se, but I would just say you guys can type that top one into Desmos as is. It's going to give you a line because everything's to the first power. Because you have a quadratic, your highest exponent is squared. Make sure you type it in where you've moved the other terms. Oh, sorry, you moved that X term to the other side first. And then you can just type it in like that. And if you wanted to, you could actually rewrite the line and type it in as y equals x minus 1, move things around. But anyways, you could throw that in, and you're really looking for the intersection point. So you've got one graph that looks like that, one that looks like that. So that's what you're looking for, is where they cross. Okay, so we have everything graphed. Now we can just look at the intersection points. Again, weird decimals, right? So what you'll have to do is you'll have to take your calculator and plug in the answer choices and convert them to decimals so that you can pick the right one. So when we're on the problem, you know, like looking at, for instance, the y, probably the y would be the easiest. I just want to see what radical 3 is. So I would put that into my calculator. And I actually get 1.73. I don't know if you guys can see this. And so I'm like, okay, it's looking good then that it could be A. And I might even just confirm it by putting in 1 plus radical 3, which actually you don't need to do, because if you add 1 to it, you do get 2.732. So it's definitely going to be A.
Okay, question number 4. We got a percent question, which is great because percentages are a very commonly tested topic. So let's check this out. Now I'm going to show you, this is exactly how I do it in real time, especially when they say something like this. I'm reading that as an equation or an inequality, and I'm going to write it just as it's stated. So the number A is, that means equal, 60% greater than the positive number B. So what does that mean when we say 60% greater? It's basically like B plus 60% of B, or the way that I like to write it is 1.6 times B. So if you think about it, think about the number 100. If you're saying 60% greater than 100, you're doing 160. It's 60% of 100 added on, or 1.6 times that 100. So there's my first equation. Then we have the second equation. The number C is 45% less than A. So there's two ways I can think about it. I can do it A minus 0.45 times A. Or again, if we're removing 45%, what do we have left? We have 55% of A. Okay, so C is 55% of A. The number C is how many times B? So we're trying to get a relationship between C and B, and that's great because we can do a little substitution because A is sort of that common variable. So with the equations, we're in a really good spot. Now what I'm going to do is I'm going to take, and be careful, the 6 kind of looks like a B. So I'm going to take the 1.6B, and since it equals A, I'm going to pop it in for this A right here. So now I have C equals 0.55 times 1.6B. I'm going to use a calculator for this. Hold on. Okay, when I multiply those two out, we get 0.88. So we get C is equal to 0.88B. And the cool thing about this equation is we like immediately get to the answer. It says the number C is how many times B? It's this many times B, which means our answer is 0.88. That's how you do it. Boom, done. Okay, Laura, what are your thoughts?
Excellent job. I would have done it the same way.
Boom. Okay, we're in agreement totally, fully there. And let's go to question 5. Here we go.
Okay, so this one is an oldie. I have to say, I couldn't help myself. I had to throw this in. You might know this is from a paper test. I hate this problem.
Yeah, I remember this problem 100% because it's on one of my hardest question videos, and yeah, I don't know, I've done this one a bunch of times, but it's all good.
Well,
All right,
here's the funny thing, HUZEFA. So this is in the question bank still for the digital SAT. So I'm like, okay, it's fair game. It's a digital SAT question.
It's fair game. We got the high difficulty. Okay, let's see. And I remember this was like a multi-part one, if I remember correctly, but. Okay, let's see if I can get my head around this again. Jennifer bought a box of crunchy grain cereal. It states that the serving size is 3/4 cup and it provides 210 calories. Okay, hold on. So we'll say, I'm just going to write this out, calories. And then 50 of which are fat, 50 fat. And this is, by the way, this is just my process. When I'm reading it with all these numbers and all this stuff, I like to break it down so I can kind of get a better idea of what's going on, just assimilating the data in a way that's comfortable for me. So this is crunchy grain. And in addition, each serving provides 180 milligrams of potassium. Oh my God, so much stuff. Okay. And then, which is 5% of the daily allowance for adults. So what if that's 5%? If I multiply this by 20, I'll get the full amount, which is 3,600, I guess.
Nice.
So 3,600 milligrams of potassium for the daily amount. Okay. And then it says if P% of an adult daily allowance of potassium. Hold on, I really have to get my head around this. If P% of an adult daily allowance of potassium is provided by X servings of crunchy grain cereal per day. Okay, I don't remember this one so well as I thought. Okay, if P% of adults daily allowance of potassium is provided by X servings of crunchy grain, which of the following? Okay, I think I got it. So here's the deal. If we have one serving, right? And this is going to be the way that I'm going to hack it a little bit. So let's write this out. Servings, and then P represents the percent, right? And what is X? X is the servings. Let's write X. So I'm just going to make this really simple. I know that when X is one serving, I should get a value of, and is P represent a percent? Yeah, P is a percent. So I shouldn't get the decimal 0.05. I should get the raw number 5. Okay. Let me erase that. I wrote down way too much information. If we have 2 servings, then we should get 10. If we have 3 servings, we should get 15. This right here is enough to figure out what the right answer is, because if I just take these values, really you only need 2 coordinates, but if I take all 3, whichever one gives me the correct output that I'm expecting, I know I'm done. So let's go step by step. I can already see which is the right answer, but let's see. So if I plug in 1 here, I get 0.5. Wrong. I'm supposed to get 5. A is out. Let's go to C. If I plug in 1 here, I get 0.05. Wrong. I'm expecting 5. And now I go to D. If I plug in 1, I get 1.05. That's wrong. I'm expecting 5. Now I go here, and let's just try them all just for fun. I plug in 1, I get 5. I plug in 2, I get 10. I plug in 3, I get 15. B is the winner. Done.
Here's some things that I liked about how you did this. The first thing I like about how you did it was, and I try to teach my students this on chunky word problems, when you read a sentence, try to figure stuff out as you go, right? Like, did you see how HUZEFA took the 5% for the 150 milligrams? And whether he needed to know it or not, he was like, okay, what's 100% of the daily allowance then? 3,600. Like, and every word problem, you should be crunching numbers and just figuring things out as you go. It's a journey. So I loved that. Even though you didn't need it, you were problem solving from the beginning. And then the other thing I love is how you set up, because it's all about being organized. You set up that table and you just broke it down so simply. Like, this is better than I thought. Like, I even did it. You did, okay, 1 serving is 5%, so 2 servings is 10%, and you saw it was a linear relationship. And thank you so much for recognizing it's in percent form. So we don't want to pick a decimal answer. If they ask for it in terms of a percent, you're going to have whole numbers, which is why B makes more sense. That was awesome.
Yay. All right, cool. Great way to end it. So we have this horrible problem from back in the day creeping back up here, but we got it. We got through it. And that's it. We're going to do another 10 in a second video, but make sure to check in the comments below. Let us know what you think about this. Give us a like if you did enjoy the video and the back and forth and all that good stuff. This was super fun for us. Laura, thank you so much for doing this with me. This was a blast, and we're going to do it again, hopefully again and again and again, because I think this is really cool for people.
Yeah, no, thank you so much for having me. I had so much fun, and yeah, hopefully it was helpful to everybody that watched it.
Awesome. All right. Thank you guys so much for joining, and we will see you in the next video. Take it easy.
All right, guys, that's it for this video today. I hope you really enjoyed this math battle that we had and found our tips, tricks, and shortcuts super helpful. Do me a favor and comment below and let me know what your favorite problem was from this problem set, or what problem gave you the most trouble and why. And if you have any other ways of solving them other than what we talked about, I would love to hear that too. If you found this video helpful, also make sure to show me some love and hit the like button below. And until next time, guys, happy prepping.